We have liftoff of the Titan Centaur carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
Some worlds in our solar system are closer than others, yet more mysterious. Voyager 2, launched in 1977, journeyed farther than any human-made craft, reaching Uranus and Neptune and sending back glimpses of planets we can barely imagine. Its signals take hours to reach Earth, yet they carry stories of frozen winds, sideways axes, and distant, silent landscapes. While the outer giants remain remote and unreachable for most, humanity has also wrestled with the fiery closeness of Mercury.
Two spacecraft going to Mercury. When they arrive, they'll split apart and make measurements of Mercury's composition, its structure, its magnetic field, its atmosphere, and try to understand the evolution of the planet itself. And actually, by focusing on things like craters, we might be able to understand what's underneath the surface of the planet.
And the crushing clouds of Venus. Every mission, every signal is a testament to our relentless drive to explore the unknown. The challenges of visiting distant planets. The outer planets of our solar system are some of the most mysterious and difficult places for humans to explore. Uranus and Neptune, in particular, remain elusive worlds. Uranus sits about 2.9 billion kilometers from the Sun, while Neptune lies even farther, nearly 4.5 billion kilometers away. Reaching these planets is not just a matter of pointing a rocket and firing it into space. The immense distances make travel slow, communications delayed, and power for spacecraft difficult to maintain. Even sending a small probe requires careful planning that can take decades to execute. Voyager 2 is one of the few spacecraft to visit these icy giants. Launched in 1977, it took advantage of a rare planetary alignment that occurs only once every 175 years, allowing it to swing from one planet to the next using gravity assists. This mission provided humanity with its first close-up views of Uranus and Neptune, revealing tilted axes, faint rings, and a collection of mysterious moons. Voyager 2's journey highlighted how distance challenges both spacecraft engineering and human patience. Signals take hours to travel back to Earth, meaning that controllers must often make decisions without immediate feedback. Every data packet sent is precious, each image a triumph over distance and isolation.
If I look at Mercury, those big space weather events happen every day. So what I'm trying to do is understand the physics of what's happening at Mercury and apply that to the Earth to try to protect.
Closer to the Sun, Mercury presents an entirely different set of challenges. Its proximity to the Sun means that any spacecraft traveling there must contend with intense heat and strong gravitational pull. Navigating Mercury's orbit requires precise calculations, as even minor errors can cause a probe to miss the planet entirely or be pulled into the Sun. Temperatures on Mercury fluctuate dramatically, adding further complexity to instruments and thermal protection systems. Despite its small size and closeness to Earth, Mercury is deceptively difficult to explore, demanding ingenuity in engineering and navigation. Venus, on the other hand, is nearby yet far from hospitable. Its thick atmosphere of carbon dioxide and dense clouds of sulfuric acid make optical observations impossible from the surface. Temperatures soar above 450 degrees Celsius, hot enough to melt lead. Any probe attempting to land must survive crushing pressures, scorching heat, and corrosive conditions, even for a brief period. Venus's harshness contrasts sharply with its closeness, illustrating that proximity does not equal accessibility. The challenges here are both physical and technical, testing every aspect of spacecraft design. Exploring these worlds is more than a technical task, it is a human story. Each mission to Uranus, Neptune, Mercury, or Venus reflects human curiosity, determination, and courage. Engineers and scientists face dangers not in the traditional sense, but in the form of unknown environments, mechanical failures, and the vast void of space. Success is measured not just by images or data returned, but by overcoming obstacles that once seemed insurmountable. The distances, the heat, the pressure, and the isolation all serve to remind us how remarkable it is that we have glimpsed these far-off worlds at all. Early Mercury missions. Mercury, the smallest planet in our solar system, has always been a challenging target for exploration. Its close orbit around the Sun makes it one of the hardest planets to reach. Any spacecraft heading toward Mercury must carefully navigate the Sun's immense gravitational pull, which can easily alter its path or even pull it into the Sun. Early attempts to study Mercury relied on clever planning and precise calculations to overcome these challenges. NASA's Mariner 10, launched in 1973, became the first spacecraft to visit Mercury. It used an ingenious method known as a gravity assist, or slingshot, by flying past Venus to gain speed and adjust its trajectory. This allowed Mariner 10 to conserve fuel while reaching Mercury safely. Between 1974 and 1975, Mariner 10 conducted 3 flybys, sending back the first detailed images of the planet's surface. These images revealed a landscape covered in craters, much like the Moon, with long cliffs called scarps that hinted Mercury had contracted as it cooled over time. The mission also confirmed Mercury's surprisingly high density and its iron-rich core, providing evidence for a weak magnetic field. The mission was not without its difficulties. The spacecraft carried a tape recorder to store data, but it often malfunctioned, forcing engineers to improvise alternative methods for data storage and transmission. The intense solar radiation exerted tiny but significant forces on the spacecraft, requiring constant course adjustments. Every signal sent back to Earth traveled millions of kilometers, testing both the technology and the patience of the scientists and engineers involved. Despite these obstacles, Mariner 10 was groundbreaking. It proved that even a small, harsh, and sun-scorched planet could be studied in detail. The mission laid the foundation for future Mercury exploration, teaching valuable lessons about spacecraft navigation, trajectory planning, and the importance of gravity assists. It also inspired generations of planetary scientists to continue studying Mercury, leading to more advanced missions like Messenger and Bepi-Colombo, which would explore the planet even further. Mariner 10 showed that exploration is not just about reaching a destination, it is about understanding the challenges, adapting to unexpected problems, and celebrating each discovery, no matter how small. It was humanity's first close encounter with a world that, while small, held secrets that would reshape our understanding of the solar system. The transit of Venus and early Venus missions. Long before spacecraft, astronomers watched Venus cross the Sun, a rare event called a transit. In 1769, observers around the world carefully timed this passage. By comparing measurements from different locations, they calculated the distance from Earth to the Sun, a vital step in understanding our solar system. This early effort showed how observation and ingenuity could unlock cosmic mysteries. Fast forward to the space age, and Venus became a target for unmanned missions. The Soviets launched Venera 1 in 1961, aiming to send the first signals from another planet. Unfortunately, contact was lost shortly after launch, highlighting the risks of deep space travel. Meanwhile, the United States tried its own missions. Mariner 1, intended to reach Venus, failed during launch, emphasizing how even small technical errors could end a mission. These early attempts were more than experiments. They symbolized the growing space race between two superpowers. Every failure taught lessons in engineering, navigation, and communication over millions of kilometers. Humanity was learning that reaching other worlds demanded patience, precision, and daring. Venus, shrouded in thick clouds and extreme heat, challenged explorers at every turn, yet the desire to visit it never faded.
Now first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you.
Mariner 2, the first successful interplanetary probe. In 1962, Mariner 2 became the first spacecraft to successfully reach another planet. Its destination was Venus, a world hidden behind thick clouds and extreme heat. The journey was not easy. Signals from the tiny probe were weak, and engineers had to carefully adjust its course to stay on track. At one point, a short in the solar panels threatened to cut power, testing the team's problem-solving under pressure. When Mariner 2 flew past Venus, it sent back data that amazed scientists. Temperatures on the surface were measured at hundreds of degrees, confirming the planet's hostile environment. Instruments found no magnetic field and little radiation, giving the first detailed look at conditions so different from Earth. Each measurement was a small victory, proof that human ingenuity could reach across millions of kilometers. Beyond the scientific findings, Mariner 2 represented a major emotional achievement. In the early 1960s, the space race between the United States and the Soviet Union was intense. Success with Mariner 2 was a morale boost for American space exploration, showing that careful planning, teamwork, and courage could overcome technical challenges. This mission laid the groundwork for all future interplanetary probes. By proving that reaching another planet was possible, Mariner 2 transformed ideas into reality. It also reminded humanity that even a small spacecraft could carry our curiosity, determination, and hope to the farthest corners of the solar system. The Venera program, Soviet innovations. The Soviet Union responded to the challenge of exploring Venus with the Venera program, a series of missions that tested the limits of technology. Early probes, Venera 4, 5, and 6, were designed like diving bells to survive the crushing pressure of Venus's atmosphere. Temperatures reached 500 degrees Celsius, and the surface pressure was about 75 times that of Earth, conditions that would destroy ordinary spacecraft in minutes. Each mission built on the lessons of the previous one, improving cooling systems, parachute designs, and the durability of instruments. The later Venera 9 and 10 missions marked a breakthrough. These probes carried cameras and transmitters, allowing humanity to see Venus in a way that had never been possible. For the first time, black and white images of the surface arrived on Earth, showing rocky plains and mysterious formations. The orbiters acted as relays, sending signals from the landers back to mission control, while the landers were pre-cooled to handle the extreme heat during descent. The Venera missions lasted only a short time on the surface, often under an hour, but every second provided invaluable data. Atmospheric readings, chemical analysis, and surface images slowly revealed a planet that was alien yet scientifically rich. Beyond the science, the program was a story of human perseverance. Engineers and scientists faced hostile conditions, repeated failures, and technical challenges, yet they continued to push forward. Each success, no matter how brief, was a triumph of creativity and courage. The Venera program proved that even the most extreme planets could be explored, and it inspired future missions to tackle other dangerous worlds, keeping humanity's curiosity alive in the face of immense obstacles. Mapping Venus, Venera 15, 16, and NASA's Magellan probe. Exploring Venus's surface was difficult because thick clouds hid everything beneath. To overcome this, the Soviets launched Venera 15 and 16, equipped with radar systems that could see through the dense atmosphere. These orbiters mapped the northern regions of Venus, from the North Pole down to about 30 degrees north latitude, revealing mountains, plains, and vast cratered areas. Radar imaging allowed scientists to study terrain shapes and patterns that had been completely invisible before. Shortly after, NASA sent the Magellan probe, which carried advanced radar capable of higher resolution mapping. Magellan produced detailed images of the entire planet, showing signs of volcanoes, lava channels, and evidence of past geological activity. Unlike Earth, Venus has very few impact craters and no clear plate tectonics. This suggested that the surface was constantly renewed by volcanic activity, wiping away old craters and shaping the planet's landscape in dramatic ways. These mapping missions gave humanity its first true understanding of Venus's surface. For the first time, scientists could study its topography systematically, not just rely on flyby data. The combination of Soviet and American radar missions created a fuller picture, showing a planet that is both alien and surprisingly dynamic. These efforts proved that even planets hidden beneath thick clouds could be charted with patience, technology, and careful planning. Evidence of current activity on Venus. Recent observations suggest Venus may still be geologically active. The Venus Express mission detected unusual patterns in the atmosphere, including spikes in sulfur dioxide and localized infrared hotspots on the surface. These findings hint at possible volcanic eruptions or other ongoing internal processes. The spacecraft also observed small ripples and disturbances in the mesosphere, alongside unexpected temperature fluctuations. Such changes indicate that Venus's surface and atmosphere are not entirely stable as once thought. While these signs do not prove active volcanism definitively, they show that the planet is more dynamic than scientists previously imagined. This evidence sparks curiosity about Venus's internal heat and its role in shaping the planet's surface. Each discovery adds pieces to a larger puzzle, revealing a world that is harsh yet alive with hidden activity. Venus continues to challenge our understanding, reminding us that even nearby planets can hold deep mysteries waiting to be explored. Modern Mercury, Exploration, Messenger. The Messenger mission marked a new era in exploring Mercury. Launched in 2004, it faced the challenge of approaching the Sun without being damaged by intense heat and radiation. The spacecraft used a series of gravity assists from Earth and Venus to slow down and enter orbit around Mercury safely. Messenger was equipped with a sun shield and phased array antennas to handle communication and protect its instruments. Careful course corrections kept it on track, despite the Sun's strong gravitational pull. Once in orbit, the spacecraft mapped Mercury's surface in unprecedented detail. The mission revealed the Caloris Basin, one of the largest impact craters in the solar system, and provided precise illumination maps of the planet. Surprisingly, Messenger also found ice deposits in permanently shadowed polar craters, despite the planet's proximity to the Sun. After more than a decade of orbiting Mercury, the mission concluded in 2015. Its findings significantly expanded human knowledge of the planet, from its surface features to its composition. Messenger also laid the groundwork for future missions, including Bepi Colombo, which continues the quest to understand Mercury's mysteries. Voyager 2 and the Outer Ice Giants. Voyager 2 was launched in 1977 during a rare alignment of the outer planets, allowing it to visit multiple worlds with minimal fuel. This spacecraft became the first to explore the ice giants, Uranus and Neptune, planets that are distant, cold, and rarely visited. When Voyager 2 reached Uranus, it revealed a world tilted on its side, with faint rings and a system of moons that had never been studied up close. Signals from the spacecraft were extremely weak after traveling billions of kilometers, but scientists carefully decoded the data to understand the planet's atmosphere, magnetic field, and moons. Later, Voyager 2 flew past Neptune, capturing the first close-up views of its blue atmosphere and active storms. It discovered faint rings and unusual moons, showing that even the most distant planets are dynamic and surprising. Transmitting data from such distances posed a huge challenge. Engineers had to maintain precise antenna alignment and deal with long communication delays, sometimes taking hours for a signal to travel one way. Despite this, Voyager 2 returned incredible information, transforming our understanding of the outer solar system. Voyager 2's journey showed that exploration at the edge of our planetary neighborhood requires patience, skill, and boldness, inspiring generations of scientists and dreamers. Beyond the known, new horizons and future missions. After exploring the outer planets, humanity turned to even more distant regions of the solar system. New Horizons, launched in 2006, traveled past Pluto and then to Arakoth, Ultima Thule, revealing icy worlds at the edge of our Sun's influence. Its observations showed that even faraway objects hold clues about the early solar system and planetary formation. Future missions continue this journey. Bepi Colombo, for example, is now on its way to Mercury, using multiple gravity assists to navigate the Sun's intense pull. Upcoming Venus missions aim to study its thick clouds, volcanic activity, and mysterious surface changes. These missions highlight the importance of orbital mechanics, careful planning, and gravity assists to reach planets and smaller bodies. Each probe extends our vision, showing that exploration is not only about science, but about humanity's deep desire to understand the unknown and reach farther than ever before. Humanity's journey across the solar system shows the power of curiosity and determination. Despite harsh environments, long distances, and frequent technical problems, we have sent probes that carry our questions, dreams, and ingenuity. Each mission, whether to Mercury, Venus, or the farthest icy planets, reveals not just facts, but stories of courage and creativity. These robotic explorers connect us to worlds we cannot visit ourselves. And as new missions prepare to venture even farther, we are reminded that exploration is endless. Our desire to know, to reach, and to understand continues, guiding us toward the unknown edges of space.